Hello everyone, my name is Edison Hong, and this is the third lab of physics, which is the black hole. So today's agenda is exploring the foundations of gravitational force and Newton's second law, going through different closed script models here, finding out possible errors, and answering further questions on what it means and a secret what if question. So, what are the foundations? So, here are the foundational physics. So, Newton's second law, which is change in mass over change in time, and the change is so small, so we have to use the derivative of the momentum. And then next, we have to expand it using the product rule to find the parallel and perpendicular components in the terms of momentum. And as you can see here, we have the gravitational force, and we have the star as the system and the surroundings as a black hole. So rearranging the gravitational force formula, we'll get the mass of the star. So now glow script. So as you can see, this glow script model, we have the seed, which is my email that generates unique values. And to get an accurate measurement for the mass of the black hole, we would need to know the momentum of the star and what the change is at multiple instances around its orbit of the black hole. And in this case here, I set the initial conditions there, and I implemented the velocity in the x and y component of the star, and it'll be calculated at every given timestamp here. And as you can see from there, I have the formulas for calculating the star velocity. So here are a few more equations I went through to find the parallel and perpendicular components of momentum to find the net force acting on the system, which is the star in this case. And the last line here is the most important one, because we can calculate the mass of the black hole at each given time increment using the change in momentum over change in time over the net force calculated times the distance between the square and GM, as you can see there. So from the previous slide, we are going to compile the results here, and I'm going to be playing this video. And here we have the star orbiting the black hole as shown through the components of the parallel and perpendicular components of this net force. And the orbit isn't circular, which means we have different net forces on the star, and when you are closer to the black hole, the force is actually greater. So I'm going to calculate the mass at each given time interval stamp, and I got the average mass of 9.83 times 10 to the 33 kilograms. And so now we're on to more coding. So I'm trying to figure out the initial velocity of the spaceship so it doesn't have a crash with the planet or the black hole. And the mass of the black hole was from part 1, and then I put the constants that we know, and then I put the initial planet speed and velocity, and through trial and error we can see what the speed and velocity are, as you can see here on the bottom. So as you can see, we have to isolate the system and figure out the net external forces. So the planet is acted upon black hole and ship, as you can see by the first formula. We're going to calculate the net force by using the universal gravitational formula, as you can see here. And the ship is acted on by the black hole, by the planet, which is another formula there. And we want to figure out the motion of both our systems over time. So we're basically iterating the position and velocity using these net forces, as you can see on the bottom. So as you can see here from the code we just compiled, the graph shows the spaceship leaving the system successfully over an hour. So what kind of possible errors could we have encountered? So approximations are actually one of our possible errors. So the simulation there does not actually represent reality, and it also assumes that there's no external forces acting on the system. Another possible error would be accuracy. The trial and error could be way more precise with velocities that could get the spaceship closer to the black hole, and more precision could do that as well. Now let's answer some further questions. So what does this actually all mean? So one of our questions is, how is the net force and its parallel and perpendicular components different from the rate of change of this momentum in its components? So they're actually the same mathematically. One is actually easier to measure than the other. So it's easier to find the momentum than it is to find the net force. So for the net force, you must know each outside factor exerting a force on the system. And the rate of change of momentum is that you need to know the system's change in velocity or motion. So, what initial velocity does the spaceship need to orbit around the black hole? So as you can see here, the magenta is orbiting the spaceship around the black hole through trial and error, and I increased the timing as well, and there we got the x and y velocity initial. Thank you.